In this question, we will do detailed analysis of this position time graph. As you see this position time graph, the one for the one bicycle or the graph is curved, whereas for the other bicycle, this graph is a proportional line. Okay. So our first question is identify any instant at which the two bicycles have the same velocity. Okay. So the first of all, what is the basic concept? Before doing this question, you must know that the velocity is the slope of position time graph. Okay, so it means that for the curved graph, the position velocity will be changing because slope is changing, right? And for the straight line graph means for the B, this velocity is constant. So this straight line is for the car bicycle B and this is for the A. Now remember that if the graph is the straight line, which means that for that straight line, the slope of this graph, which is is the velocity. If it is moving along x-axis, or we can say Vx, is constant. It's very important point that it's constant, and if it is constant, it means that acceleration is not produced for the car, for the bicycle B. Okay, but what about A is showing us a curved graph, and for this curved graph it means that velocity is changing. Now let me show you by zooming it in that there is only one instant of time where the both velocities are equal, and which is almost at this point. So students, this is a time at where we can see that the velocities will be equal. And why is that? Because if I draw the tangent at this point, right, so you can see this tangent line is parallel to this graph for the bicycle B, which means that the both slopes will be equal, because we know that the slope of two parallel lines are equal. So the velocity of the bicycle B is equals to the velocity at the time t, or you can say at t. So now let's address our next question, that is about which bicycle has a larger acceleration. So that is obviously the bicycle A. Why is that? Because the we have seen that for the bicycle B the acceleration is 0 because the velocity of the bicycle B is constant. And why is constant? Because it's moving with, like, its displacement or its position is increasing uniformly over time. But what about the A? So this graph shows us the increasing slope. All right, increasing slope. Why is that? Because if you draw the tangent at any, let's check at any 2 points. Let's say at this point, if I draw a tangent line, and then at this point, so you see that the tangent line is becoming more steep with passage of time. So we can say the slope is increasing, which means that the slope means the velocity is increasing. And if the velocity is increasing, it means that acceleration is obviously not 0. Okay, so now the third question is at what instant or instants the bicycles are passing each other and which bicycle is passing the other. Okay, now to answer this question we have to go deep dive into this graph. And let's say this is a point. Let us consider these are the 2 points where the graphs are intersecting. This is a point 1, this is the first instant, and this is the second instant. Okay, now you have to carefully see that, like, the velocity at B is not changing. Okay, it's a constant because the graph is a proportional line. But look at it, look at the one. If I draw the tangent at the this point at the time point 1, so remember that this is a tangent on the curved graph at this point, and you can see that it is obviously, this tangent line will be less steep, okay, than the straight line graph. Okay, what does this less steep means? It clearly means that the slope is less. Okay, so delta x over delta t for the car A. Okay, for the car A at the instant 1 is less because you have seen the tangent line is less steep. So this is more. So delta x over delta t for b. Okay. So it means that at the instant 1, which we are calling, the VA is less than VB. So it means the bicycle A is moving slowly. Maybe it's behind, and so B is heading actually A at the instant 1. So now let us see at the instant 2. So if I draw the tangent at the point on the curved graph, so you see that now this tangent line is more steep than this for the bicycle B. So at instant 2, we have seen that the slope of the tangent line for the car A is obviously more because we have seen that it's a curved graph, so velocity is continuously increasing, so that's why it will pass the bicycle B. Now the next question is, which bicycle has the larger instantaneous velocity? Now, what is the instantaneous velocity? It is the velocity of that moving object at certain instant of time. So you know the slope of this graph is velocity. So for the bicycle B, this velocity we have already seen that it's a constant. Okay, it means that for it, the instantaneous velocity will be equals to its average velocity because velocity is not changing, right? But what about A? For this, I will code this graph again, which we have discussed few minutes ago. You can clearly see at this instant of time where the velocity at A is more than the velocity at B. Okay, velocity of the bicycle B. So obviously we conclude that the instantaneous velocity for bicycle A is more than B. Now the last question is, which bicycle has the larger average velocity? Okay, now here let's revise again. What is average velocity? How do we calculate average velocity from the graph? Okay, so as I had already explained you that the average velocity for B is actually equals to instantaneous velocity because this is a straight line graph. But let's see in more depth. Okay, now for B, I we know that the average velocity for the B is actually the rise over run. Okay, that is the slope of the graph. Okay, this is the rise. Okay, for the B it is the change in delta x for B, so I am calling it delta x for B. Okay, whereas you can see for A it is less. So what you have seen that the displacement, the position, change in position for B is more than the change in position for A. Now let us see the time. And in the same pattern, you see the time taken for the bicycle B is more than the time taken for the bicycle A by almost the same amount. Which means, dear students, the average velocity for the B, okay, the average velocity for B is approximately equals to the average velocity for A. As you have seen, rise over run, the total values for both of them almost same, because whenever we find out the average velocity for the curved graph, so we consider the initial point and the final point and we calculate its value. So delta x is actually, this is a delta xa. So average velocity is approximately equal. That's how we have answered this whole question. I hope you will like the video and subscribe this channel, support this channel. So take care. Bye.